Welcome to springlib.
The first step in this problem is to get the quantities and units that agree with one another. So we have V is equal to 161 kilometers per hour, which is the speed of the rocket after the first 8 seconds. V naught is assumed to be at rest. And it helps if we get this kilometers per hour into meters per second, which is what everything else in the problem is in terms of. And so the way we do that is we multiply by a conversion factor. If we put kilometers in the bottom and meters in the top, the kilometers will cancel and we'll be left with meters. 1 kilometer has 1,000 meters. And then we also need another conversion factor for the hours. In this case, hours goes on top, seconds in the bottom. 1 hour has 3,600 seconds. And this is equal to 44.7 meters per second. We're also going to want to do the other velocity, because after a full minute, the final velocity is, I'm just going to put an 8 there to indicate that that's after 8 seconds. And then this is after 60 seconds, is 1,610 kilometers per hour. Doing the same conversion factors on it to convert it from kilometers per hour to meters per second gives us 447.2 meters per second. And now we can proceed with the actual problem. In part A, we're asked to find the average acceleration for the 2 time intervals from 0 to 8 seconds and from 8 seconds to a full minute. And so let's worry about the 0 to 8 seconds first. Now the formula for the average acceleration is the velocity at the end point, in this case it's 8 seconds, minus the velocity at the beginning point, which is 0 seconds, divided by the time of this interval, which is just 8 seconds. Now we found on the previous part what the velocity at 8 seconds was. It is 44.7 meters per second. And so plugging that in, velocity at 0 seconds is just 0. And then we're dividing by 8 seconds, and we get an average velocity of 5.59 meters per second squared. I know these are the correct units because I made sure to convert the velocities to meters per second before doing the calculation. Now we can do the second part, which is the average acceleration for the 8 seconds to 60 seconds interval. And so same formula, except I'm just going to plug in 60 here, minus the velocity at the beginning, which in this case is the 8, over the time interval of that, which is 52 seconds, 60 minus 8. And in the previous part, we found both these values. And so this becomes 447.2 minus 44.7 over 52. Oh, pin's glitching out. Sorry about that. We're 52. And this is equal to 7.74 meters per second squared. And that's the answer for part A. In part B, we're asked to find the distance traveled during those 2 time segments. And so let's worry about the 0 to 8 seconds first. Our initial velocity is 0. The time elapsed is 8 seconds. The final velocity is 44.7 seconds, or 44.7 meters per second. And we're going to use x minus x naught is equal to 1/2 v naught plus v times t. This is just a kinematic equation. Our unknown is this x minus x naught. It's the distance traveled during this process. And when we plug in our knowns over here, we get that x minus x naught is equal to 178.8 meters. And my pin's glitching out again. But that's the final answer. Now for the second time interval. Our initial velocity is 44.7 meters per second, because that's the velocity at 8 seconds. We want 8 seconds to 60 seconds. Our final velocity is 447.2 meters per second. And the time interval is 52 seconds. And we're going to use the same formula, x minus x naught is equal to 1/2 v naught plus v times t. We have a t value, we have a v naught plus v value, and then we divide that by 2 and get the distance traveled. And we get 1,200 or 12,789 meters. And so these two are the final answer for this part. And that's the end of the problem.